Welcome to our third math online lesson for grade 4. This is Ms. Fatima Bilhaj, and today is April 9th, 2020. In the previous lesson, we stopped at question number 17, which says, Maria invited 4 of her friends over for a water balloon fight in the backyard. At the start of the game, Maria gave each of her friends 2 water balloons. She had 1 water balloon for herself. So how many water balloons did they have all together? In this question, I have to work first on the number of water balloons that her friends have, and then on the 1 water balloon that she has. Now for each of her 4 friends, I can simply add 2 4 times, or just multiply 2 by 4. The answer in both ways, or in both cases, is 8. Adding to that, the 1 water balloon that Maria has for herself. Now 8 plus 1 equals 9. So the number of water balloons that they all had together was 9. For question number 18, Hind and Hala's mothers told their daughters they can swim in the pool for 20 minutes. First, they swam laps in the pool for 7 minutes. Then they swam underwater for 1 minute. Then they played water polo for 8 minutes. How much longer can they stay in the pool? Now, the amount of time that they were allowed to play in the swimming pool was 20 minutes. So I will take away the 7 minutes that they swam when they swam laps in the pool, 1 minute for underwater, and 8 minutes for water polo. So what is 7 plus 1 plus 8? That's 16. Let's take away 16 from 20. 20 minus 16 is 4. So the longer time they can stay in the pool turned out to be just 4 minutes. Number 19. Siraj, Muad, and Abdurrahman went bowling together. Siraj's score was 55. Abdurrahman's score was exactly double Siraj's. That means I'll take Siraj's score and multiply it by 2 in order to get Abdurrahman's score. Muad had 13 fewer points than Abdurrahman. Fewer points means lesser points than Abdurrahman. So I'll take Abdurrahman's score and subtract 13. What was Muad's score? I will show you both Abdurrahman and Muad's score right now. And in order to know their scores, I have to start with Siraj's, which is mentioned in the question as 55. And now I will work Abdurrahman's, which was double Siraj's. So 55 multiplied by 2, which is the same as 55 plus 55. The answer is 110. Now Muad's, which was 13 fewer than Abdurrahman, or lesser than Abdurrahman. So 110 minus 13, which is 9. Before we move on to the following question, which is number 20, there's an important concept we need to revise, which is equivalent fractions. Equivalent fractions are equal fractions, even if they seem to be different than each other. For example, 1 over 6 is equal to 2 over 12. Even though 1 is not equal to 2, the numerators are not the same, and 6 is not equal to 12. That is, the denominators are not the same. I will show you why. Let us take the same example one more time. 1 over 6. Now, how many parts will I shade out of this shape on the right side? I'm going to shade only 1 part out of 6 parts. Next, in order to get an equivalent fraction out of 1 over 6, I'm going to partition this area into 2 parts. Partitioning this area into 2 parts is the same as multiplying both numerator and denominator by 2. 1 multiplied by 2 is equal to 2. And 6 multiplied by 2 is equal to 12. Let's have a look at the shaded area. I still have 2 green blocks out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the new fraction is 2 out of 12. Simply, you can just count 6 by 2. For the following fraction, again, I'm going to shade 1 out of 6 parts. But in this case, I'm going to partition this shape or this area into 4 equal parts. partitioning it into 4 equal parts is the same as multiplying both numerator and denominator by 4. What is 1 times 4? That's 4. What is 6 times 4? That's 24. Now, looking back at the green shaded area, I still have 1, 2, 3, 4 blocks out of 1, 2, 3, 4, 5, 6 by 4, which is 24. So 4 out of 24. Now, I have found out 2 different equivalent fractions for 1 over 6. There's a little homework at the end I need you to do. Before we move on to the following one, some might tell me, why did I use blocks? We normally use circles to represent fractions. So let us draw a circle and represent the same fraction. I'm going to partition the circle into 6 equal parts, or cut it into 6 equal parts. Then I'm going to shade 1 part out of these 6. And again, I'm going to partition each area or each part into 2. How many shaded areas now? 1, 2, out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 2 out of 12. For question 20, complete the calculations to make one whole. First, I will count how many parts do I have in the first fraction. 8 parts. So both denominators will be out of 8. And I will make sure I will get one whole at the end. One whole complete circle. Okay? I can start by shading only one area, or one part, sorry. And the first fraction in this case will be 1 out of 8. So the unshaded will be 7. 1 out of 8 plus 7 out of 8 are equal to 1 whole. Now let us take another option. I can shade 3 out of 8, and the unshaded will be 5 out of 8. Still, 3 out of 8 and 5 out of 8 are equal to 1 whole complete circle. Another option, and these options are all correct, by the way. Another option can be shading 6 parts out of 8. And the unshaded, in this case, unshaded parts will be just 2. For the second fraction, I have 3 parts, so my both fractions denominators will be out of 3. I can start by shading only one area, and the unshaded area or parts will be 2 out of 3. 1 out of 3 plus 2 out of 3 are equal to 1. I can shade another one, but I'm going to have the same fractions in both cases. For question 21, match the equivalent fractions. On the left side, 1 out of 6, 1 out of 3, 1 out of 4. On the right side, 3 out of 12, 3 out of 9, 2 out of 12. I will start by finding equivalent fractions for the fractions on the left side. Now let us work out question number 21, match the equivalent fractions. 1 out of 6, as we have found out together earlier, is equivalent to 2 out of 12. So I will match 1 out of 6 to 2 out of 12. For the second fraction, we have 1 out of 3. We can find an equivalent fraction by multiplying by 2. 1 times 2 is equal to 2. And 3 times 2, it must be 2, not 3. I have to multiply by the same number in the numerator and the denominator. Both by the same number. So 2 out of 6. But I don't have 2 out of 6 as an option in my worksheet. So I will try to find another equivalent fraction for 1 out of 3. Let us try to multiply 1 out of 3 by 3. 1 times 3 is equal to 3, and 3 times 3 is equal to 9. Oh yes, I do have 3 out of 9 in my worksheet. So I'll connect 1 out of 3 to 3 out of 9. For the third fraction, 1 out of 4, again, I will find an equivalent fraction by multiplying by 2, but I don't have it. So I'll try to find an equivalent fraction by multiplying by 3. 1 times 3 is equal to 3. And 4 times 3 is equal to 12. Referring back to our worksheet, I'm going to connect 1 out of 6 to 2 out of 12, 1 out of 3 to 3 out of 9, and 1 out of 4 to 3 out of 12, like that. For question number 22, think of addition, adding two numbers, and the answer is equal to 2. I can of course think of adding 2 plus 0, and I can also think of adding 1 plus 1. Of course I have another option to think of right here, which is whether this 2 was actually 12, and I wrote 2 down there, and I carried 1 up there. In this case, of course I will have to fill in with 9 plus 3, because 9 plus 3 is equal to 12. Now, next digit, 10's place value, I have 1 plus 5, which is 6, but I have 0 down there. That's not possible. So this 0 must have been 10, and I wrote the 0 down, and I carried the 1 up there. Now, what's 1 plus 5? We said it's 6, so we need 4 more to make it to 10. For the third option, the 100's place value, I have 1 up there. I can only add another 1. I have no other options. The second question, 1 minus something equals 4. Okay, that's not possible as we know. So this 1 must have been 11. And I have borrowed from the neighbor. Now, what is that number when subtracted from 11 equals 4? The answer is 7. Then let's think of the 10's place value. Something minus another thing equals 5. Now I can write any option in the second number starting from 3, for example. If I write 3 down there, on the top I must have, I must write 8, right guys? 8 minus 3 equals 5. But remember that I have borrowed from the neighbor? That 8, I'll make it turn into 9. Because when taking away 1 for the unit's place value, I will have a correct calculation. 8 minus 3 equals 5. As for the third place, 100's place value, I can think of 9 minus 8. Last thing for today's lesson is the homework. How many equivalent fractions can we get out of 1 out of 6? Please don't hesitate to share your answers on Viber, and I will see you next time, guys. Take care.